All right, welcome everyone to this week's Xojo webinar. I'm Paul Lefevre, the Xojo Developer Evangelist. And this webinar is part one of a two-part webinar series. And the topic is DB communication with Xojo. And essentially, we're going to talk about how you can use middleware, essentially, to have an iOS app or any other type of app communicate with something like a database. And before we dive into all that, I'm going to give kind of an overview of what this concept is and explain how it can be used. And then we're going to create a few apps that can communicate in this manner. And then in part two is when we'll actually dive right into some of the more details in dealing with databases. So this is essentially laying the groundwork. Feel free to ask questions. I can see the question window on my other screen, so that looks good. And we'll get started. So when you're commonly making database apps, you generally are going to have client app and a database server. It's going to look pretty simple. The client's just going to talk directly to the database server. There's nothing else around. The two are connected. Often there's a persistent connection between the client and the database server. So if that connection goes away for any reason, your app no longer can communicate with the database server. Your app may start raising errors or even crashing if you haven't accounted for that situation. So this is what you commonly see in database design. And this design can work perfectly fine. It's particularly useful for in-house applications that are running on a local network, where you know the quality of the network, you know that latency is going to be really low. You know right where the database server is. Usually it's hosted nearby. And so this is a common design you see. And of course, more than one client can connect to the database server, so you can have a whole bunch of them. Now, the concept with middleware is we're going to essentially put something in the middle here, as its name might imply. So we're still going to have a client. We're going to have something called middleware. And we're still going to have a database server. So you get your three pieces right here. The client only is going to talk to the middleware. The middleware is going to communicate with the database server, but it's also going to communicate with the client. So it's kind of going to do both of those jobs. And you can, of course, have multiple clients. But like I mentioned, all the clients are only ever going to talk to the middleware. Now, this is a much more flexible design, as you don't have the direct connection between the database server and the clients. The clients are talking to middleware. It allows you to put a buffer in front of things. You can handle things a lot differently. And we'll see how this can work in particular, but this has a lot of applications. So how do you do this sort of thing with Xojo? Well, it's actually relatively straightforward. You're going to use a web app for the middleware. And the web app is going to communicate with the database server. The clients are going to communicate with the web app using HTTP and JSON. And they're going to do this using one of two event handlers that Xojo provides in its web apps, the handle special URL event handler or the handle URL event handler. The handle URL is a new event handler that was added with Xojo 2014 release 3. And they both work similarly. It's just different controls over what the actual URL is that you're communicating through. But these are both events that are on the app itself, on the app class. So to see how to apply this technique, we're going to start pretty simple. We're going to have a web app that can essentially send out movie quotes. Now, because we're starting simple, we're not actually even going to even use a database for this at this point. This is just going to be an array sitting within the web app. And we'll see how you can use get and post to the web app to get back a quote, random quote. We're going to use JSON to send data around. There'll be an actual web app, and then we'll have some clients that can communicate with it. A desktop client, an iOS client, and if we get time, also another web client that talks to the web app, which will end up, the code will be exactly the same as the desktop client. So let's switch over to Xojo. All right, so we're going to create a new project here. So we have standard looking Xojo web app. Now, the big thing about this is, generally speaking, you're not going to have a UI for this type of app, since you're only going to be handling requests into those one of those two event handlers. Your app isn't going to need any specific UI. Well, we're going to build a little one here just for information purposes, but I mean, realistically, you're not really going to need one. All right, so first thing that I will do here is I'm going to add a property. And that's just going to essentially serve as our stand-in for a database, if you will. That will oops, hang on, I got a wire over my keyboard. It's not letting me type. All right, it might work. That will allow us to just have some simple data to serve up without having to deal with the additional complexity of talking to a database at this point. So essentially, we're going to just populate our little array with some rinky-dink quotes. We'll create another property here just so we can generate some random numbers. So that's just when the app starts, we're going to have a few simple quotes to work with. Nothing too fancy there. But the other thing, the next thing to do here is you can see there's two event handlers here, handle special URL and handle URL. Handle special URL is going to let you handle any URLs that go through as it's noted here, the special or the API part of the URL. Handle URL would allow you to handle pretty much any URL that was sent to your web app. We're just going to use handle special URL now since it's been around longer, but the code is really not going to be any different between the two. All right, so you can see right here that this, when it's called, passes in a request as a web request, and it returns a Boolean. So what you want to do is, if you're actually going to be returning results back to the client that called you, you're going to return true from here, and you're going to send the information back in the request that was passed along here. And if you don't want to handle anything, you're going to return false. So the first thing we want to do is check the path of the request. And this will essentially be something that looks like that. Actually, I think that is just special is the part that we want, not special URL, but I'm going to check that here. Yeah, the path will actually be something like this. So our URL will be whatever is the URL is for the web app, with this appended at the end. And if we call the web app with that as our URL, it will get, this event handler will get called. It will be able to identify that we actually put /quote at the end, and then we can run our special code. If we called it with a different thing here, you know, something else, special /Xojo or whatever, it wouldn't fall into our case statement. It would end up returning false, and it would say page not found. All right. So if we know that we have been requested a quote, we can now put together the request to send back to the client that called. So the first thing is we're simply going to get a quote. Nothing too exciting here. We're just grabbing a quote from the array, random quote from the array. We can then package this up into a JSON item. So we create a new JSON item. We just set the value of quote equal to whatever quote we happened to get back. And then we can call the print method on that JSON string data so that it becomes available for the client, and we can return true to tell it that we are returning valid data. And that's it. So this is going to send information back to the client that submitted the request. Now let's set up our little simple web page here with just a little bit of helpful notes. All right, so I've just got a little bit of text note here, and there's going to be a URL. This is a web link control that's on here, and you can see the code for this is it's just going to fill in whatever the URL is for the running web app. And our first test of this will be that the web app itself will kind of just returns data back to a web browser. So the client, the original client for our little example here, will be Safari. All right, so we have our little app. We've got a link here. You can see what the actual URL link would be to call this stuff, and I can click this. And it opens up a new tab, and now Safari in this tab is essentially the client to our little web app, and it returns the JSON text here. Very simple, but that's what it looks like in raw JSON format. So now we can actually build real clients that will take this raw JSON and parse it out and then display what it wants from it. So we can build a little desktop app that would only show, you know, the actual quote that gets returned. And you can see it pulls back different ones. And that'll be a very simple example of how that communication could work. So can leave that running, but might as well stop it. We'll look at the next one. So that's the middleware piece. Now you can see that this middleware piece right now is incredibly simple. There's just a little tiny bit of code in the handle special URL that's getting the quote, packaging it up, and returning it. And we're just right now issuing a simple GET request. We're not passing in any data or anything like that. We're just returning back a random quote anytime someone sends a request here. And we'll beef this up in a little bit with a little bit more stuff where we can pass JSON data into this thing, parse it out, and use that information. But for now, this is on a very simple level what it's doing. And of course, you know, as we'll look at next week, you know, the code to make this work essentially with databases just is going to involve this web app being able to connect to whatever database you want to use, and then being able to package up stuff to send back to the client, and to unpack stuff that it got from the client. So that's going to be a lot of busy work, but you'll have to, design things to work the way you want and that sort of stuff. But we'll look at that more next week. So let's talk about now creating a desktop app that will be able to request a quote from a web app and then simply display it. All right, our desktop app is going to also be rather simple. So because this is a web app, and I mentioned earlier, all the communication is going to be done using HTTP. So we're going to want to use an HTTP socket for this. So I'm just going to immediately add one right here to my project. And I'm not actually even going to bother putting any code on it. I'm just going to drag it in here. I'll add a button. And I'll just throw in text area here to display the quote that gets returned. Now, in order to essentially call the web app, you have to send it a request. Well, that's pretty easily done using the HTTP socket. We'll just send it a GET request, and we put in the URL. And that's the actual URL. This will be the URL when the web app is running locally here on my machine. If you had your web app hosted elsewhere, of course, you would use the actual URL to it. But that will essentially call the web app. Now, in order to handle the data that comes back from the web app, we need to implement one of the events on the HTTP socket. And we want the page received event, and this will be called when the data is returned. And there'll be, there's a few parameters on here, but the one that's mostly important for what we're doing here is the content parameter, which is going to have the actual content that the web app has essentially sent back using that print command. And in our case, we're sending back the JSON data. So we just need to essentially grab the data and then convert it to a JSON and then extract out the value we want. So that's easily done in 3 simple steps. The first thing when you're dealing with this stuff is to make sure you set proper encodings. Now, in most cases, you're going to be dealing with UTF-8, but you are going to need to specifically, you need to be specific about that. You have to say that it's UTF-8. If you don't, the encoding will be unknown, and the text probably won't look how you expect. It might have some weird characters in it. So this just makes sure that we're taking any text which we happen to know is UTF-8, and we're just saying, hey, this text is actually UTF-8. Now, the text we're getting back is the raw JSON. This is what you saw in Safari when Safari was displaying it. Safari doesn't know how to parse any of this stuff, so it just threw the raw JSON right up there for you to look at. So we can take this raw JSON text and we can actually load it into a JSON item with one line of code here. And then we can extract out the specific value we want, like so. So we know that we want the quote that's associated with the value quote. So that'll be whatever text is with that. So that's it. That's the code that's going to handle receiving the data back from the web application. And this is the code that essentially calls the web application. So if I go back to my Write projects, and I have a lot of them open here, we can run our web app again. And I can leave that running. And then we can run this project. And of course, fix any names. I didn't give the text area. Actually, I didn't give any of my things my nice names. Oopsies. All right, so I'm trying to get both of these on the screen here at the same time. All right, so we can see the web app is running, and I can click the Get Quote button, and I can get back quotes. And the web app here that is running behind the scenes is getting all these requests, sending the JSON data back, all being parsed, displayed here on the desktop app. Nice and simple. I guess we'll just leave that running for now. So that is a desktop client that is communicating through that. And of course, any number of desktop clients could communicate to our running web app. So now we can make an iOS app that will communicate in the same manner. Now the code is going to be a little bit different because we're using the new framework with iOS, but the structure is going to be exactly the same. So the first thing I'm going to want to do is add a class. And I'm going to go over my view, and I'll just drag it here onto the view. And like I said, the structure is the same. So on the view here, I'll add a button. I'll add the text area to show the quote that we get back. I'll remember to give it the right name. And the same sort of thing. We just need to call the web app. So we can use get here. Slightly different syntax. I'm calling the send method here and telling it I'm doing a get, and then providing the URL. And now we can go to the equivalent event here, which is also called page received. And this comes back with a couple parameters here. Content is the parameter that has the data that's coming back. Now you notice this is a memory block, so we're going to need to do a little bit more handling of it to convert it down into JSON. So this is a memory block, but we know it contains JSON data, and we know the JSON data is UTF-8. So we can use the text encoding class to tell it to take and convert the data that came in into UTF-8 and stick it into text variable. So now we have our response is raw JSON text. Now we can convert this JSON into a dictionary. So we just create a dictionary, we call the parse JSON method with the text, and it essentially builds a dictionary out of that. And then I can get the quote value that I want. Pretty much the same as before. So you can see that doesn't look a lot different than the desktop quote client, the page received code. Very similar. Still have roughly 3 lines of code, but 3 steps that are being done. And now we can run the iOS project. And it works the same way. getting back quotes and displaying them just as we hopefully would expect. I definitely don't want to do that. So it's didn't click on the right window. All right. Now, you can actually have a different web app be a client to a web app. So you could actually do the third step here, which is create a web app. And this will use the same, actually, because this will use the same exact code, I'm just going to copy and paste it from the desktop quote client project. So I can just take this guy here, paste it in here. Add the action event handler. Take its single line of code and paste it right in here. So you can see, I mean, other than the different UI objects, the code is exactly the same with the desktop project. The only other thing I need to do here is change the port. And no, it looks like I got a different debug port. I just need to verify that I'm not using the same debug port as the middleware, because that won't work so well. All right, good. So if I run this one, I get it in its own tab. This is the actual middleware web app that's running here. And I can call that, and this separately running web app is calling the web app that's running here and getting back the results the same as the desktop and the iOS app are. All right, if there are any questions on that, now would be the time to ask them, because the next thing we're going to look at is, right now we use get to do all of these requests to the web app. But now we're going to take a look at post, which is probably the technique you're going to use most of the time, because it provides a better way to pass the data into the web app. All right, let's see. I got a couple questions here while I get the next part set up. Juiced is asking, we'll go quite fast. Downloads will be available. Yes, all the webinars are recorded. This one's being recorded, and the downloads are always available the next day or so. I am trying to go as slow as possible in this one. So if you've sat through a lot of webinars, I think you might rate this as one of the slower ones. But it might be a lot of new information for people. So certainly you take advantage of the recordings, play, pause, try stuff. I'll also have all these projects available afterwards as well that you can download and take a look at. And John is asking, what's the advantage of using middleware over directly connecting to the database server? Well, one of the big advantages of using this particular technique with HTTP is that it's stateless. So there's no persistent connection between any of the clients and the middleware. Each time a request is sent, a new connection is made, a request is sent, data comes back. So that has an advantage on stuff that might have an intermittent connection. It might be a little more efficient from your server perspective. Having a lot of hard connections open can be pretty expensive for the server. And as I think I mentioned earlier, just in general, if you always assume you have a hard connection to the database server, which is what you often do when you're building in-house apps, and then you kind of throw that up somewhere where the connection might not be quite so persistent, you may lose the connection. And direct connections to databases, when you're constantly losing connections, don't often work the way people like them to. So then you're constantly checking if you're still connected to the database, or you're having to, connect to the database each time, which can be a more expensive operation. So it's just a different type of database design. And this technique is just significantly more flexible. One of the big reasons that I'm showing this again now, I think I did this on a high level a little while ago, is because iOS does not have any ability to directly connect to database servers. That's just not something it can do in general. So this particular technique is required if you need to connect to a database server from an iOS client. All right, so looking at our little middleware app here, yep, that's the right one. We can tweak it a little bit so that it can handle a post request sent to it with additional data. So here I've got a method. I guess I can just create it. So here we'll essentially just have this method be responsible for taking the data that came in on the request and kind of doing something with it. And we'll call it from the handle special URL event. So the first thing we want to do is actually get the data. The data is available on the entity property of the request. And again, we need to tell it the encoding so that things work how we expect. We're dealing with text here, so essentially UTF-8 is going to be what we want. But we need to be very specific about that. And our data that's coming in is going to be JSON. So we can just take that data once it's been converted over to simple text and then use it to create a JSON item. And we haven't mentioned what our JSON incoming data will look like, but it'll have a value called type that'll be the type of movie quotes that we want to return. Right now we only have just 6 movie quotes. It's not a heck of a lot. But when you start to think about dealing with databases, you're going to want to be providing parameters, specific things that tell you what type of data to fetch from the database. So this will just be a simple example of how to parse that. Like I said, next time we'll see how this all can be tied into usage with a database more specifically. So this little thing is essentially just getting the data from the entity, converting it over, putting it in a JSON item so we can extract out the specific value that we want. So then we can call this from here. And it can be something pretty simple. So I can just check if our process, oops, I don't need a closing parentheses there. I can call our little method here, sending in the request that came in. And if it was able to parse out that movie quotes are being requested, then we can get our random quote and return it. And if we had it set up so that we had different types of information we wanted to return, if I had non-movie quotes, I don't know what, politician quotes or something like that, and you had them set up separately, you could have, select case or another else here to check for that, and then return those type of quotes. And of course, when it comes down to the database side, you may have specific requests for customers or address or whatever. And this starts to give you ways to parse out that information so that you can fetch specifically what was requested. Now this is taking in the post request. So that means our requests that the clients are sending off here need to be done a little bit differently. Right now we were using get and just sending the URL in. We weren't sending along any data or anything. So we'll need to tweak those a little bit. All right, so we don't need the get anymore, as we're going to do a post. All right, so our simple data that we're passing in isn't very sophisticated. Like I said here, it's just JSON with value of type set to movie quotes. I then convert the JSON into actual text, and then I send it using a post. So I set the request content as the JSON text, and I tell it essentially to type. I haven't actually URL encoded it, but for simple purposes, it'll suffice. And then I call the post and just give it the URL. All right, so again, I should be able to just get the run button visible so I can run our updated middleware app. And run the updated desktop. And it still is returning back the quotes. And if I go back to here, you can actually see the process. In the debugger, you can see, we issued our request. The middleware web app is now fired up in the debugger because I set the breakpoint. I can step into the particular method. I can see that it got the what the post data actually looks like. Well, not without resizing. You can see it looks like raw JSON. And then I can convert that and it pulls the value out. So it all works like we want, which is good. And as I continue to mention, this is kind of a skeleton, the simple idea that we'll build on when we're doing database type stuff. But all these techniques will just be used with simple matter of adding more code around them to handle the database input and output and stuff. So you can see the changes were only slightly different here. The send data call, this was a get before. Now it has additional code to actually package up any information we want to send off to the web app. Our web client would use this exact same code, of course. The iOS client uses similar but slightly different code. As soon as I bring that one up, I will share that mystery code with you. So same sort of setup here. still creating the information you want to send. In this particular case, on the iOS side, you're creating it as a dictionary. That then gets converted to JSON text by calling the generate JSON method in Xojo data. And now we have JSON text. The HTTP socket on iOS communicates using memory blocks because there's no, because that's how it works, and we don't want to think people this is actually plain text. It needs to be an actual memory block. So that is converted down to a memory block, telling it that we want it in UTF encoding. And then we just send along that data, same sort of format, and we call the post with the URL. So again, it looks very similar to how the desktop and web code looks. It's slightly different for the slightly different commands that are available. I don't remember if I kept the web app running. I guess I didn't. And again, that works the same way, sending the data in, getting the data back. All right, I got a question here from Edwin. Is it possible in an iOS app to create a class with a record set class and interface and have it communicate under the hood using JSON with a web server? Yeah, we'll talk about that more in part 2. There's going to be an infinite number of ways you can build how you want to do the communication and design, your API essentially. One thing that is almost always discouraged is you don't have it too low level. So you don't want to build up an API where you're putting in the JSON like actual SQL. And then your web app receives the actual SQL and the JSON just runs the SQL and then sends that information back. Generally, you're not going to want to do that. That's not the greatest idea from a security standpoint. And that really doesn't provide a very command or object-based mechanism for getting information. It's a bit better to have actual commands that say, get me the customers, and then you call that, you package up a JSON document that essentially has that command in it, and then the web app says, all right, I got the command to get the customers. I know what SQL I should use to get that. It does that. It packages everything up and sends it back. And then if it turns out you need to tweak the SQL to add a new column or something like that, your client apps aren't affected. They're still calling the same command, and they're just getting back a JSON document that they can then parse. All right, just going to mark some of these questions as answered so my list doesn't get too long. All right, so let's go back to a few slides here. Now, the other thing to consider when you're building this sort of thing is authentication. You're probably going to want to ensure that only approved clients are communicating with the middleware. In the case of our little quote app here, now it doesn't really matter. It's just sending back quotes. There's no, personal information there. There's nothing that's private. They're just, fun little quotes. But if you're actually connecting to a database that has information that should not be publicly accessible, you're not going to want to just have an open API that's returning that information. Even though people won't necessarily be able to directly hack into your database using this method, they still might get back data that they shouldn't be seeing. So one technique we'll look at, well, we're not going to look at this technique, we'll look at the next one, but one technique that I've seen commonly done for this sort of thing, and again, there are a lot of techniques for handling authentication and security and that sort of stuff. But one thing I often see people do, probably because it's pretty simple, is set up a VPN so that the server is not actually publicly accessible. people that need to access it have to have VPN software on it, connect through the VPN into the network that contains the server, and then they're able to send web requests to that particular server. This is more of something that might be useful for, a specific app that's for a specific company that's only used by a fairly small number of people. If you have a larger app that's used by a lot of people, or anybody really, you might want to use a technique that I've seen called tokens with SSL. And essentially, you generate some sort of token. It can be anything, really. GUID is a common thing. And then that gets assigned to a user or an app. And then when a connection is made, the token is always supplied. And then you look up to see if that particular token is allowed to have access to information. And the benefit of this is you can revoke a token if you need to for some reason. And then whoever's using that token would no longer be able to get information. They would just get, you would have your handle special URL set up to just return false there, and they'd get a page not found. And SSL, of course, is something you'd want to set up so that people can't sniff the requests and figure out what the tokens are. But that technique is probably one of the more common ones that I seem to find when I was doing some research on this. There seem to be a lot of other ones as well. I didn't have a lot of experience with them, and so I'm not going to list them all here, but there's lots of ways you can go around and figure out this stuff. And but the token and SSL one seems like the most straightforward one to work with. Now, essentially, what we've created here is a web service. This is would essentially be a REST web service using representational state transfer, which essentially just means we're using HTTP with one of its protocols and some standard data encapsulation format, in this case, JSON. You could certainly use XML as well. I'm using JSON for these examples because Xojo iOS has the ability to handle JSON. It does not yet have the ability to handle XML. So if you do want to build an app that can be processed by an iOS client, you're going to want to stick with JSON. And JSON does have the advantage of being a bit more compact than XML, and seems to be the more commonly chosen data transfer format right now. So if you don't have a legacy one you need to deal with, starting with JSON probably does make the most sense. Which brings up, as I note here, this, all this talk about being able to connect to a database, that's more of just a specific use case of this, because it's not just for databases. This particular technique can be used for anything. So if you have a long-running process that you want to offload to a server, you can use this particular technique so that you can send a request up to a server, have the server do whatever it needs to do, and send the results back to the client. So any task, really, that can be better handled by a server rather than a client. And this is particularly useful if you're building mobile devices. You don't want to necessarily kick off a high CPU, expensive process on a portable device that's running on a battery and then kill its battery. So it might make sense to send the request off to the client, or send it off to the server, let the server deal with that. Maybe you get a nice beefy server that is handling all that stuff. The server could actually, or the web app that's on the server could maybe even spin off a separate console app to do the busy work, and then get maybe a whole nother CPU core to do that work. So a lot of flexibility there. This sort of thing also can be used for data syncing. Of course, it can be used for a database, which is kind of the initial impetus for this whole discussion, but that's not its only case. And certainly, I suspect that most of you are using apps on your various devices, phones, computers, or whatnot, that use this particular type of technique. So this is very common. And the other thing to remember with this technique is that anything can be the client. It doesn't even have to be a Xojo app. You're using standard protocols and techniques here. So we saw in our very first thing that Safari itself was the client to our Xojo web app. Didn't do anything terribly useful with the JSON data it got back, but There could have been some JavaScript running on that Safari page that was able to take that JSON and do something with it. Really, any language is going to be able to take back, is going to be able to send these HTTP requests and get back the data and do something with it. So it's a nice open technique that doesn't lock you in. So essentially, you now have beginning idea of how to make web services with Xojo. And like I mentioned, this is part 1 of part 2. Next week, we'll focus more on the database part, which was the original title of the webinar. But in order to get there, I think we needed to go through all this overview stuff so that everyone has a good understanding of it. I don't exactly know what we'll do for a database thing next week, but it'll probably be connecting to a SQLite. So it won't even necessarily be a real database server, but it could be if you wanted it to be. So yes, in part 2, we'll use an actual database, probably SQLite, and we'll just have some examples that we'll let you get and update data on the SQLite database that is sitting on the server from a client of iOS and from a desktop client as well. All right, let's see here. Got a few questions on my list. I'm going to scan now. All right, Edwin is asking about using the crypto classes to encrypt JSON data back and forth. Yeah, that would probably be perfectly fine as well. Your keys would need to be, the decryption keys would, and stuff would need to be on all the clients and the servers as well. It's possible you could maybe even use public-private key stuff for that. But yeah, that's all techniques you can apply to this sort of thing. Mark is asking, what is required to deploy the middleware to an actual server? Well, the middleware, like I said, is just a Xojo web app. So you need a web server. You need a server, really, that you can deploy it to. Obviously, Xojo Cloud works really well. Any server that you can deploy any Xojo web app will work fine. Standalone web apps make very good middleware, and those generally are pretty easy to deploy. So you'll need a web license, of course, and you'll need some server that's accessible to you. But that's really it. All right, let me just mark off a few here, get through this list. All right, Fotis is asking, do you have any idea how many requests can be running simultaneously with no problem? Well, not specifically, no. I mean, how many requests you can handle depends on, how long each request takes to handle. So, if you're handling database requests and you're kicking off a bunch of database queries and those are all taking a really long time, that could delay how many requests are being processed. So, I mean, that's the sort of thing, much like with pretty much any deployed web thing, you have to do some sort of load testing, have an understanding for how many people might be using your software to be able to figure out, in general, if it's going to work just as is with a single app sitting out there, or if you need to put some sort of load balancer in front to spread the wealth amongst multiple instances. That falls under, pretty much standard stuff you have to do when you're optimizing web apps for large usage. And then related to that is something about requests being queued. I don't specifically know if requests are queued. I suspect if the server is too busy to handle things, requests might get lost. But you're a little beyond my understanding of how that might work at this point. That might be a good thing to ask in the forum. Maybe you get Greg to give you the definitive answer on that. Off the top of my head, I do not know. Fotis is asking if you need to encode the JSON text in case it has. Yeah, that I kind of glossed over that. Yeah, you're going to want a URL encode that stuff. I suspect that it is being sent along as actual data and not text. I didn't try any specific tests with invalid characters to see if they got messed up or not. Never hurts to URL encode things. But I probably would want to do a test to see if that's 100% required. In the past, I've always just done it. But now that I think it through, I'm not sure that it's always necessary, at least with the post request. It's definitely necessary with any gets. Let's see here. Jim is asking if each request takes place on a separate thread. Yes, web apps do handle things on multiple threads. So as requests come in, they're threaded out. But you got to remember, Xojo uses cooperative threading. It's still going to only be running on a single CPU. So that does put an upper bound on how many threads it'll practically be able to handle at one time and how many requests it'll be able to handle at one time. That's what can make, and pretty much most web technologies have that issue as well, PHP and whatnot. And that's where a load balancer can help, because it is very fast at getting a request in and then doling it out to spread the load amongst multiple things. And again, it really matters, if you're building something like Twitter or Facebook, obviously those are extreme and you'd be doing a lot of that sort of testing. For the average app that's used by, a single company or something like that, most of this can be a non-issue. All right, hang on, I got to clear out some more questions. I can see the next ones. All right, is it possible to have, Mateo is asking, is it possible to have a console app to handle the middleware stuff? Well, you could, but the thing about the middleware stuff is it's going all through the HTTP protocol. Now, by itself, a console app is not, it's just a console app. You could certainly build a console app and put in server sockets and all the code necessary to handle that stuff, but I would think it would be a heck of a lot simpler to just use a web app, which is kind of designed for that purpose. What you can do is have the web app spin off console apps to do processes that are longer running. So if you do have, something that's doing some serious calculation and you don't want, the main app to be tied up with that and possibly miss any requests, you can just spin that off to a console app. Console app will launch, get its own CPU allocated or core allocated by the operating system, do its thing. That would communicate back to the web app, which would then communicate back to the client that then initiated the request. So that particular technique would work fine. All right, that was the last question on the list. And perfect timing, just about 1 hour. Well, like I said, this was part one of part two. Part two next week, we'll focus on database stuff. Come with questions. And like I said, this is still being recorded. The recording will be posted in the next day or so, along with the examples of the projects I went through. So you'll have time to grab and review this stuff and be all ready for part two next week. Thanks everyone for attending. Have a great day.